Hey, I'm Maximo Anderson. I'm with Team 190 as the head of the Collector Design Group and the director of some of the preseason courses. This is my submission for the 2021 Design Innovation Scholarship. In this presentation, I'll show you how my team has incorporated many innovative ideas into our CAD robot. This year's robot is specifically designed to be easy to fix in case of a collision or a breakdown, and to fit under the trench to reduce cycle time while scoring points. Let's start with the Collector. Compared to last year's Collector, this year's Collector is a relatively simple design that is sturdy, space efficient, and fast. It consists of an intake wall with 3 sides and a single rubber-coated PVC roller that spins at 3,300 RPM, allowing balls to be sucked in quickly while we're driving at full speed. The Collector moves along 2 linear guide rails located on the sides of the robot above the wheels, which are sloped downwards 5.2 degrees to avoid hitting the bumpers. The extension of the Collector is actuated using 2 pistons located below the guide rails. In order to ensure the Collector retracted in less than a second, I used physics to find the force of the piston required to overcome the weight of the Collector and the friction on the guide rails. We also include a safety factor in our calculations to ensure a smooth operation of the Collector. When a ball sitting on the field touches the roller of the intake wall, it is pulled into the bumper, then pushed up until it rolls to the next step of the ball path. The next step for a ball is a hopper that can hold 5 balls, which the team affectionately calls the Chaos Bin. This Chaos Bin is designed to collect a ball from the ground with the Collector while also being able to collect from the human player station without any serious modifications. From last year, we learned that contrary to common sense, the best way to store a ball is not to hold on to them tightly. So, to prevent jamming, balls are agitated in the bin with an omni-wheel driven by a mini-sim motor geared down to a ratio of 25:1 to spin at 240 RPM. With the extra degree of freedom, the balls are collectively moved clockwise in the bin by the omni-wheel so that they are moved around each other and pushed onto the ball path entrance on the left. After the hopper, the ball enters the ball path. The ball path starts at a 2-inch in diameter compliant wheel to kick the ball to a poly-belt conveyor, which then feeds the ball into a 5-inch diameter shooter wheel. An interesting part about this year's ball path is that we can preload 3 balls to shorten the time it takes to complete our auto. Another subsystem on our robot is the shooter. The team decided not to go with a turret this year because aiming could simply be achieved by the drivetrain alone. The shooter has 2 775 Pro motors that rev the 5-inch in diameter neoprene rubber wheel to 6,000 RPM. The wheel is positioned at the top of the ball path, forcing the ball through 2 position hood. The stored position, which shoots balls at a 75-degree angle from vertical for close shots, while also allowing us to pass under the trench. The hood can then deploy to a 30-degree angle from vertical for long-distance shots. With machine learning, we are able to determine if an object on the field is a ball by using a mobile net retained on a PowerCell database. The hardware we use for that is a Raspberry Pi and a Google Corral tensor processing unit. During auto, our robot will use trajectories to help us drive from the power port to collect balls off the ground. First, we plug in coordinates and headings. Then the robot will follow these curves for auto. Using feed-forward control, the robot can correct for any errors if the robot's path is interrupted by another object. Without 190's team spirit, these innovations would simply not materialize. Every year, we name our robot Cross with a Go. This then drives our shirts, hats, hoodies, and whatever swag we want to wear. When we're not building robots, we get to know each other outside of engineering. We play games or stay late after build hours to discuss things like sailing, BattleBots, or whatever else we want to talk about. Along with that, we are really proud of the courses Team 190 has created for its new members. I am personally proud of the role I played in creating 3 of these new courses. Over the summer of 2020, a team of 6 planned courses for Mass Academy students to learn about programming in Java, CADing with SolidWorks, and how they could participate on our team. Each new student was more prepared for the build season, and they kept coming back because they wanted to learn more. It's like our excitement for creating fancy code, parts, and ideas rubbed off on our new students because a new set of juniors are working to create innovations as we speak.